Hello, welcome to this second part of the DevOps metrics with GitLab. This time it's change failure rate and mean time to recovery. Last time we discussed deployment frequency and lead time for changes. And before I go into the other two metrics, I would like to give you a small video in which we show you a quick overview of all four metrics.
The DORA key metrics, developed by DevOps Research and Assessment, are performance metrics that measure the effectiveness of an organization's development and delivery practices. These are deployment frequency, lead time for changes, time to restore service, and change failure rate. This is a project for the public-facing about.gitlab.com website. Deployment frequency measures how often an organization deploys code to production or releases it to end users. In this graph, for which you can select the date range, you can see that for this GitLab project, hundreds of deployments have been taking place on a daily basis during the last week. This puts this project into the high category, meaning multiple deploys per day for this DORA metric. Faster delivery of features can translate into higher levels of user satisfaction and retention, higher quality of code, and an increase in adoption of your solution by new users. It can also help identify and address bottlenecks in your development and delivery practices to speed up your time to market and allow your developers to spend more time innovating. Let's move on to lead time for changes, which measures how long it takes to go from code committed to code successfully running in production. In this chart, you can see that the median time between a merge request being merged and deployed to a production environment for last week is 1.8 minutes. Putting this project into the high category, meaning a lead time for changes between 1 day and 1 week for this DORA metric. Shorter lead time for changes can help identify and address bottlenecks in your development and delivery practices, allowing developers to spend more time innovating and delivering value to the business. In addition, getting fixes to end users faster can translate into higher levels of user satisfaction and retention and increased adoption. This is a Ruby on Rails sample application. Let's check its DORA metrics: time to restore service and change failure rate. Time to restore service measures the time needed to restore services to the level they were previously in case of an incident. In this graph, you can see that the time to restore service is 0 days, specifically 33.6 minutes, putting this project into the high category, meaning a time to restore service of less than 1 day for this DORA metric. Faster recovery from a service outage and fast turnaround on bug fixes can help deliver higher quality of code. Let's move on to change failure rate, which is the percentage of changes to production or release to users that result in a degraded service and subsequently require remediation. In this chart, you can see that the change failure rate is 10%, putting this project into the high category, meaning a change failure rate between 0% and 15%. Lowering change failure rates can help preempt production problems and outages. These can lead to a lower risk of violating service-level agreements with end customers. Since GitLab is a tool for the entire DevOps lifecycle, information from different workflows is integrated and can be used to measure the success of your software development teams. The DORA Metrics dashboards streamline the evaluation of the effectiveness of your development and delivery practices. They can provide insight and help you better measure and improve what matters in relation to your software delivery and performance. As teams evolve from a DORA low level to the high level, organizations can experience these benefits, such as increased adoption and user retention, lower risk, faster time to value and market, and they can keep or improve their competitive edge.
Yes, so this is just a quick overview of what the metrics are, and they mentioned already the high, medium, and low categories. Here are the categories in a list in an overview. Whether you are in the high, medium, or low category doesn't really matter. Whether you're in the change failure rate of 16 to 30% or 46 to 60%. What matters is try to be better at what you are doing. Measure the metrics to improve your own team's software delivery performance. Not for someone else, no, for your own team to be better at what you're doing today. And to try and move up to high performance, on-demand deployments with a low lead time for changes, a low mean time to recovery, and a low change failure rate. If you do that, then these metrics will be of tremendous value for you. So how are these metrics measured in GitLab? Let's go and start again quickly with deployment frequency. Again, deployment frequency is the average number of finished deployments into production. And you need this CI/CD code snippet to achieve that, which includes an environment keyword with the name production. And we've seen that last time as well, but this is important because even with the stability metrics, this is important again and as well. Lead time for changes is measuring the time between the merge request is merged and the production deployment is finished. And it takes the median age in seconds between for each of the merge requests in your deployment. Then let's go on to change failure rate. Change failure rate is measuring the number of incidents against the number of deployments. So in this example, you see that there have been 6 production deployments in the time, and in that same period of time, you have 3 incidents. This leads to an average change failure rate of 50%. The lower the number of incidents, or the higher the number of deployments, the lower the change failure rate will be. And this is also how GitLab is measuring it. It's measuring the number of incidents and it's measuring the number of deployments in a given time frame, and it will divide the two, and then you have your change failure rate. Time to restore service then is measured based on a median of the duration of an incident. So it will take your incident, and for example, this one here, the incident is opened at T0, time 0, and then in 20 minutes it's closed. So therefore the incident duration is 20 minutes. For the second one is 25, 35, 20, and 15. And it will give you a median of 20 minutes. The median is calculated by taking all of the values in order from small to large, so 15, 20, 20, 25, 35, and then you take the middle one, which is 20 minutes. So that's the time to restore service. If you want to track these two, time to restore service and change failure rate, as I said, these are measured against production deployments. But it also requires GitLab incidents to be tracked. Not other incidents, no, they have to be GitLab incidents. Because if you have a GitLab incident, it will give the DORA metrics the start and the close or the end time of that incident. All incidents have to be related to a single production environment, and it has to be a strict one-to-one relationship. How are we trying to achieve that? There's no way of assigning an incident to a production environment, so we need to make another way of ensuring that, and that is the following. So we have a project. A project typically has one Git repository. That's how that works. And in that project, you can report incidents. In the same project, you will also have a CI/CD pipeline that will do deployments. These can be review app deployments or staging deployments, but we typically measure the production environment deployments. And you can only have one production environment in that project for the DORA metrics to work correctly. And then we have this one-on-one relationships. You have one production environment on your project, and you have the incidents on your project, and therefore the relationship is one-to-one, and we can measure change failure rate, for example. Let's have a look at where to find them. So again, CI/CD analytics, change failure rate is given a graph. In this case, it's a demo. No, it's not a demo. This is change failure rate, which is very low, 1.5%. Over time, you see the amount of changes happening. So mostly there were no changes, and then here you see there has been a few changes. And you can see then how many, and that is used to calculate the change failure rate. Time to restore service, same thing. Per day, it will give you the time to restore service for that day, so the amount of incidents that have been opened and how long they have been open for, and then over time it will give you a median over that time, which is the red line. Now let's look at how that will look like in an actual environment. So I have here a test demo environment which will deploy something to a Pages website. Here I have the environment which will give me a production environment after I do the production deployment. That will give me this website. And the change failure rate is measured against incidents. So you have here incidents here. Here you see there's 2 open incidents and there are quite a few closed incidents, 7 in total. And these are used to measure the change failure rate. So these are created 3 days ago, but they are closed within that same day. If I go to CI/CD analytics, then you see that the time to restore service in this case is 7.7 minutes, because incidents are typically in the demo open for just a short period of time. And I will add a few to it in a minute. And the change failure rate, again, is also depending on the number of deployments. I deliberately added a few deployments manually to lower the change failure rate. It was 200% because there were not that many deployments happening, but I added a few incidents. Now it's down to 69% because I added a few deployments in the last 90 days. If you look at last month, you see that the change failure rate goes up because the time frame is smaller and the change failure rate in the last period of time was quite high. So this helps you again in drilling down, okay, when was the problem? Last week you see 87%, so there was a problem somewhere in last month, but not in last week. And that's due to, indeed, here, May 3rd, we had a 200% change failure rate. That's how you can drill down. Okay. Now, incidents, I said you need to have the incidents tracked in GitLab, but not everyone is tracking incidents in GitLab. You can also track incidents somewhere external, for example, in Jira or in any other issue tracking tool. So how would you then work? First of all, if you want to measure your deployment frequency, you want to measure no, you're not your deployment, your change failure rate, sorry. If you want to measure your change failure rate, you want to measure the number of incidents happening on production deployments or production environments, let's say. And in many cases, these incidents result from alerts triggered by a monitoring system. They can also be incidents coming from end users that tell you, hey, there's a bug or there's a performance issue. But normally or mostly you would like to try to be proactive and have monitoring tools that will alert you when something is wrong with production. This monitoring is something that is also available in GitLab, and in GitLab you can integrate with Prometheus, for example, Prometheus alerting or Obscene alerts. And from these alerts, you can automatically create GitLab incidents and also close them by sending a recovery alert. And this alerting system can also work with custom configurations as long as you can send a JSON payload to it. And on top of that, you have a built-in status page that can notify customers on ongoing incidents or alerts for that system. what is a typical service management flow that I see? Now, as I said, you have applications in production that are being monitored and will result in alerts. You can also have other resources that will result in alerts, for example, log file analysis, or, as I said, incidents from third-party systems. That could also result to an alert being triggered. Now, when that alert is triggered, then you can, with a tool like Opsini, you can distribute that alert. For example, you can send it to GitLab, but you could also send the same alert to other systems. If you send it to GitLab, then that alert is registered in GitLab, and you can configure it in a way that automatically an incident is created from that alert. And there you have your incident start time, so to say, that is used for your mean time to recover, to restore. Once the alert is finished, but the alert ceases to exist, so to say, you can trigger another event that's called the alert recovery event, and that will automatically close the incident. So if, for example, in this resource, an incident is closed, you can send that recovery event here to also close the incident in GitLab. Now again, how does it look in GitLab? So I also already showed you incidents in GitLab, but here you have the alerts, which are related to the incidents. So I have 5 resolved alerts here. Alerts are configured on the project in the monitor section, and here you can configure how that payload, so to say, how that JSON payload that is sent to GitLab is handled to trigger the alert. So you have the alert that requires a few fields. That's the left side, and you can map them to the fields in the payload. So any custom payload will work as long as you have information that will give you any of these fields. You don't have to fill in all of the fields. You can also do a subsection as long as start time and end time are being registered, because that's important to determine the mean time to restore. And also the fingerprint is used to find back an earlier. So if you want to close an earlier event with the end time, that's the recovery alert, then with the fingerprint, it will identify that one. So let's see how we can trigger that. What I've made is I've created a quick shell script that will send a payload to GitLab, and that shell script will then trigger that alert. Sorry. Let's go here. So let's trigger the shell script. Create alert. Summary, demo alert, describe alert, test for the demo, unique ID, demo 1, severity is high. This has a specific set of values, critical, high, etc. And then this will send data to GitLab. And now if I reload here, you see that there's a new demo alert created just now with a severity of high. You can go into it and you see the values that I've put in. Also the fingerprint is here, everything. And this has resulted into an incident that you can see here. And also because I added the production environment, it also adds this one to the, it should have added this to the production environment. That's with demos. Sometimes these things won't work as you expect them. Environment is set correctly. So maybe I should close this alert. And then See if that will move. Yeah, now you see the other incident was critical and therefore more important and overruled my high incident here. I can also use a recovery alert event to close this alert. And I go back to this and I say close alert. I only have to give you the fingerprint here, and then it will close. You see here it's referring to the same ID, the same internal ID, and now it has closed this one. So here you can see now this one is closed, and also the related incident is now closed. Demo alert. This should also increase the analytics here, but that usually takes a bit of time. So that's not immediate. I can see here today the time to restore service is now 1.6 days because I closed that other critical alert that has been open for a couple of days, and that has now resulted in a time to restore of 1.6 days, and the change failure rate is now 100%. Also, probably because of the number of deployments do last week. You see now, just now it was 87%, now it's 100%. So the number of deployments matches the number of incidents. So yeah, it immediately makes it, updates it now. 1.6 days is still within range, and the median is still 4.2 minutes. So that's still quite good. Yeah, so that's how you could include a third-party system and make those events trigger alerts in GitLab, and that will register incidents automatically. And with that, I would like to thank you all for listening. This is the end of this presentation, and I hope you enjoyed it and you learned a lot of it.